This meeting is being recorded.
Hi, good afternoon, everyone. I hope everyone is doing good and safe amidst this COVID pandemic. Today, we are going to present on advanced artificial intelligence, and our group members are me, Sahiti Kastala, and Prapurna, and Pranay Geet. So today we are going to give the presentation on two papers. The first one is a roadmap of agent research and development, which is by Nicholas, and the second paper is on multi-agent learning. So coming to the agents are nothing but computer systems that can do a flexible autonomous actions, and agents can be a human agent or a robotic agent or a software agent. And these agents are being widely used in many applications, and agents, they run by perceiving and thinking and also by acting. So agents perceive the environment using the sensors, and they act upon the environment using the actuators. So basically, it is composed of both actuators and sensors. And coming to our paper presentation today, so we are mainly going to discuss on multi-agent systems and autonomous agents, as I said previously. So to represent a more complex system or to implement a complex system, we need multi-agent systems and autonomous agents. So these are two systems that represents the complex systems. So characteristics of agents include situationness, autonomy, and the flexibility. So autonomy is nothing but an agent which is able to act without any human intervention. That is known as autonomy of agent. And situatedness is nothing but agent will receive the sensory input from the environment, and it performs the actions and change the environment in a particular manner. So that is one of the characteristics of agent. And flexibility means an agent should be responsive, an agent should be proactive, and agent should be social. So agent should be responsive in the sense agent should be able to recognize the surroundings in a very proper manner and change accordingly. And agent should be proactive. Agent should perform actions proactively. So these are some of the characteristics agents possess, and some of other characteristics agents have is mobility and adaptability. So agent-based systems, we have multiple types of agent-based systems, so which are like single agent systems and multiple agent systems. Hybrid agent systems are also available. So multi-agent systems, they represent problems that have multiple problem solving methods. So to solve any complex problems, we need multiple agent systems. Coming to the autonomous agents, as I said in the previous slide, so autonomous agents are nothing but they act without any human interventions. So intelligent agents are the live example of intelligent agents can be said like the autonomous robots, which we have currently in our some of our applications that are intelligent agents. So the main contributors for this intelligent agent field is from artificial intelligence. So artificial intelligence planning research is closely involved in studying of these agents. So how agents should perform, how agents should have maximum performance, all this study is being done by artificial intelligence. So AI planning is also associated with one system called as STRIPS planning system, which is nothing but standard research institute problem solver planning system. So it basically has some components which help the agent to perform well. And subsumption architecture, which is the another architecture, which is helps in the collection of various complex behaviors, and it helps in accomplishing various complex problems of these agents. And apart from artificial intelligence, the other contributors that help in the agent field is object-oriented programming and human-computer interface. So the object-oriented programming, as we all know, the Java, so it basically deals with objects and the methods. We can see like objects have different private, public, and the other things. So the object can have its control over its thing. Like object can have, suppose if an object is declared as a private, it can only be accessed within the method. So object can have a control over its method, but so like this, using the object-oriented programming techniques, agent field is being researched a lot. And the agent architectures include hybrid architecture, and inside the hybrid architecture, it is differentiated into the horizontal layering architecture as well as the horizontal layering architecture. So the research is being done like how we can improvise these two architectures in a way so that agents can perform even more better. So the research is being done on these both architectures. So for this agent development or the agent research, there's an agent programming language that is there, which is called as Soham's Agent Zero. This is called as one of the agent-oriented programming language available that will help in our agent research and agent planning. And some of the other languages that help the developers with a set of tools for implementing these multi-agent systems are Concurrent, MetaM, and Evrel. So these are the languages that will help the developers to implement the multi-agent systems. So to provide more details or more insights on the multi-agent systems, my teammate Pranay Geet will continue on the multi-agent systems. Thank you, everyone.
Hi everyone. Today my topic is about the multi-agent systems. Multi-agent systems is derived from basically you can call it as a subset from distributed artificial intelligence. Multi-agent system multi-agent system is comprised of various systems which coordinate with each other, trying to solve a problem. Basically, the multi-agent system acts in place of users aiming to complete various goals and tasks that they are provided. Multi-agent system provides solutions in situations where expertise is dispersed spatially and temporarily. Multi-agent system also enables the interconnection and interoperability of multiple legacy systems. Such systems can be incorporated into an agent society by constructing an agent wrapper around them. And multi-agent system model problems is in terms of autonomous interacting component agents, which is more natural way of representing task allocations, team planning, and user preferences, etc. Multi-agent system efficiency retrieves, filters, and globally coordinates information from spatially distributed sources. Yeah, you can continue changing the slides. Yeah, here are the four basic characteristics of multi-agent systems. Every agent only limited information available in every agent. Basically, these are all decentralized data, depend upon decentralized data, and they are all acts on a synchronous computation, and they are all limited to the local perspective only. And there is no global perspective for the multi-agent systems. Next, we're gonna look into problems to address in multi-agent systems. Here are the couple of here are some problems that we address in multi-agent systems, are like what kind of language to be used between agents when they are addressing the problems, and what are the instructions to perform and the distribute issues, and trying to find the results, and what are how harmful can overall effect be without these problems can be seen here. The solutions to these problems are linked to courses. For example, like the range of effective coordination agents may be constrained by different modeling schemes for an individual agent. Different communication and interaction procedures have implications for behavioral coherence. Different issues and activity decompositions may result in different interactions while solving the problems. Next, we're going to see the applications of multi-agent systems. Yeah, these are the some areas where multi-agent systems are now actually being used in industrial applications and telecommunications and commercial applications. For example, when we talk about manufacturing industry is defined in a network of work cells. These work cells basically have different purposes of its own, like paint jobs and lathing and grinding, etc. These work cells then they are divided into flexible manufacturing systems, so it can be called as FMS. Each performs its specific functions, such as assembling the parts, product buffering, and so on. When we talk about the transport systems, there are actually two type of agents that come in place in transport situation. The one who represents the clients who need or can provide the transportation, or another who represents the stations where customers congregate to be picked up. The customer service representative notify the railway stations that needs the customers to be picked up. When we go into business process management, you can see many companies spend a lot of time in making a decisions which are relevant information. And it can be a time consuming process which is not very suitable for the big companies. Therefore, these companies, they have developed a variety of IT systems to aid in various aspects of these business processes. These IT project address the issues by weaving a business process as a network of negotiation service providing agents. Each agent represents a distinct role or department within the organization and can provide the solutions for this. When we see the interactive theater and cinema on the games, recently a game was developed based on the creatures, where a creature offers a rich virtual model, a variety of synthetic agents, with which the user can interact in real time in this game. The agents are designed to be sophisticated pets who develop influenced by their experience throughout their lives. The last application we're going to look at is healthcare. In healthcare, medical care system is developed, and it is intended to patient. It is basically a patient monitoring system, which typically involves a large number of people. For example, when we talk about a general practitioner, he only suspect or make assumptions that a patient has breast cancer, but the final decision that can be only made from specialist of the education. So if the professional confirms the hypothesis, a care plan for treating the patient must be developed, utilizing the resources of these other people. Okay, these are some concluding remarks for multiple agent systems. It has input it has inputs from various fields such as artificial intelligence, object-oriented systems, software engineering, and distributed areas. If we see in the past 2 decades, we have great advancements and design implementations in autonomous agents. Previously, we have looked at a lot of examples in applications where multiple agent systems are used. Okay. Next, we're gonna see multi-agent systems, multi-agent learning, which Sai Prapurna will continue.
Okay, today we're going to discuss about the multi-agent learning engineering. This comes under Pulpit 2, and multi-agent techniques are it totally depends upon the agents and its surroundings. Means the multi-agent, it refers to the software agents, and agents is nothing but it may be a robot or a living organism or a any creature, and it's a multi-agent means it can only depends upon the human agent team's collaborations. And agents are classified into 3 types. There are simple, intermediate, and complex. And here we can perform complex uh, software tools or agents in the simplest way by using these techniques. And there are 3 types of agents, and some of them are divided in divided into virtual and discrete and the continuous. And why multi-agent technique? Because here mass is used to create a structure that is needed for some domains, and multi-agent systems have a good potential to solve problems uh, that can solve the complex problems. And in the for a single member, and intelligent approaches includes the methodological reinforcement learnings or techniques. And for the multi-agent techniques, we use Nash equilibrium. This mainly focus on the game theory, and it is developed by the tuning process as well. And here we have taken example of the total gain in the market share, and there are many examples, but I have taken this example to discuss about the Nash equilibrium, and we have solved this Nash equilibrium using the continue using this equation. And first thing is we have to calculate the formulas, gain value from the formulas, and the final equation is calculated by the end of the equation's value. And the conclusion is the multi-agent techniques can perform a better version of a software tool, like not only the simplest way, but it can perform the complex uh, problems in the simplest manner. That's the use of the multiple agent agenda, and effective utilizing of the domain expertise during the design phase of to attempt a particular skill that totally depends upon the academic problems. And here are the few references that we have taken for these presentations. And thank you.